Hello everyone. I'm going to talk about a really big topic, factoring. This video is meant as an overview of the different types of expressions you can come across and the techniques I find are the most straightforward and consistent. You'll need to know how to find the greatest common factor, expanding brackets, using distributive or FOIL, and just kind of be already familiar with factoring a little bit. So let's get to the different types you can come across. Our first type of factoring is going to be the greatest common monomial factor. In this one, I'm going to be thinking about the GCF of each term. So I've got my 12x to the power 4 y cubed, and we've got our 8x y squared. So you need to think about that, and in this case, well, I think about the 12 and the 8. The greatest number I can divide both by and still get a whole number is 4. So I've got 4, and then I've got the biggest x value that shows up in both is an x, and the biggest y value that shows up in both is a y squared. So what I do is put this out front. And then I now think about 4xy squared times what is going to give me the 12x to the power 4 times y cubed. So 4 times 3 is 12. X times x cubed is x to the power 4. And y squared times y gives me the y cubed. Now we need to focus on the second term. We need to think about 4x y squared times what gives me 8x y squared. So 4 times 2 gives me the 8, and then x times 1 gives me the x, and y squared times 1 gives me the y squared. So this question's done. On to the next one. Here I need to think about what is the greatest common factor of 20a to the power of 7 b squared, 16a cubed times b to the power of 4, and the 14a cubed. So first focus on the numbers. So we're going to look at this first, the 20, the 16, and the 14. The greatest number that I can divide each of these by is a 2. And when it comes to the a, the biggest a that's possible in all of them is a cubed. Okay, so we're done. The a. And lastly, the b. Notice that the b only shows up in the first two and not in the last, so therefore we cannot put that into our GCF. So it's 2a cubed. We put our GCF at the front, and now we think about, once again, 2a cubed times what will give me my first term. So in this case, 2 times 10 equals 20. A cubed times a to the power 4 equals a to the power 7. And then we need to put our b squared because we don't have that in our GCF. Okay, now we want to move on to our second term. So 2a cubed times what gives me negative 16a cubed times b to the power 4. So we've got 2 times negative 8 gives me 16, and we've got the a cube's already there, so just a 1. And then we need to put in our b to the power 4 to have that go in there. And then finally we need to work on our last term. So 2a cubed times what gives me my 14a cubed. So 2 times 7 gives me 14, and then times a cubed. All right, so we're just good. We have 1 there. All right, that one's done. Here's one more example. So let's think about the greatest common factor of the 3b to the power of 4c and the 20d to the power of 5. If you think about that, the 3 and the 20, there's no greatest common factor there. It's just one. B to the power of 4, B doesn't show up in both, and the C doesn't show in both, so we're stuck. So this one is not factorable because we cannot find a GCF, and there's no other technique that will work on this one. The next type is factoring by grouping. This one you'll typically find has 4 terms, and you're going to factor parts of it, not all at once. All right, so we are going to focus here on 2 of the terms, and then we're then going to focus on the second 2 terms. So find the GCF of our first terms, so our AC and AD, and you'll get an A shows up in both. So that's our GCF of that. So we'll put that out front, and then A times what gives me AC? That's just C. And then A times what gives me AD? That's just a D. Now we're going to think about the GCF of our next pair. So we've got BC and BD. The GCF of that, a B shows up in both, and that's it. So our GCF is B. We put that out front, and now B times what gives me BC? That's C. B times what gives me BD? And that's a D. And look, if this is factorable, it's going to always work out that you're going to find that you have a common factor there. So this is what goes out front. So we're going to have C plus D, and then you just put in brackets your other 2 leftover pieces of the A and the plus B. And now this is fully factored. Let's do one more. Here's another one. So once again, we notice there's 4 terms. So we're going to try out factoring by grouping here, because we're going to, well, look at all these. Well, there isn't an M in everything. There isn't an N in everything. So we can't just GCF everything at once. So let's just try and do the first 2 terms, and then think about factoring the second 2 terms. So do the GCF of our first 2. And we get M is common in both. And that's it. So we are going to put that out front, and then think M times what gives me MZ? Well, M times Z. And then we've got M times what gives me 3M? So a 3 here. The next one. So we're going to look at the GCF of 2NZ and the 6N. So in this one, there's actually 2, that's a common factor in both, and an N. All right, so we put that out front, and I'm going to make this a negative 2N, and that's because you'll see here that if I go negative 2N times Z, I'm going to get negative 2NZ. And then if I go negative 2N times negative 3, or sorry, plus 3, I'm going to get negative 6N. And this is what we wanted. We wanted to get the same thing in these brackets. Now, if I didn't do this, if I had left this as a plus 2N and put, okay, plus 2N times negative Z gives me negative 2NZ. And then if I had, for the second term, if I did 2N times negative 3, that gives me negative 6N. That's fine, but look, now this and this, like this is different. And we don't want that. We want them to be the same. So by putting the -2n in front, we're going to get positives there. All right, so by putting -2n, we got our z plus 3 and our z plus 3 that are the same. So we put that out front. And then just take our other two terms and go m minus 2n. And this is fully factored. Our third type of factoring is difference of squares. In this factoring, we need to have only two terms, and we need subtraction. Our third criteria is we need to be able to square root each of the terms. All right, so what I do is I first think, okay, can I square root my first term? Yeah, the square root of x squared is x. Can I square root my second term? Yeah, that's 6. So I can notice that this is subtraction, which allows me to use a certain pattern where I take my first term, my first result here, and I add it with my second result, and then I go my first result minus my second result. So that's the pattern. You'll see it again here. All right, in this next example, I see that I have two terms. I have subtraction. Now I need to think about, am I able to square root each of them? So I've got 81 x to the power 6, y to the power 2. If I square root that, square root of a1 is 9. The square root of x to the power 6 is kind of, all you do is in your exponent you go 6 divided by 2, and then you get 3. And then the square root of y squared is y. And then for 49z squared, square root of 49 is 7. Square root of z squared is z. So yes, we can successfully square root these guys. Now, as before, we take our first result and we add it with our second result. And then I take my first result and subtract it. So you just add, then you subtract. And there it is. That's simple. In this third example, I can see that, oh, I have two terms, and I can square root this, and I can square root this, but unfortunately, I have a plus there. It needs to be subtraction. So this one, we say that it's not factorable because none of our techniques will apply here. All right, one more example of potentially difference of squares. We've got two terms, we've got subtraction. Let's see if we can square root them. 49 x to the power of 8. That gives me, square root of 49 is 7, and then x to the power of 8 gives me x to the power of 4. That one's good. And then we've got the square root of 25 y to the power of 7. If I square root that, I get 5. But the problem is, square root of y to the power of 7 is 7 over 2, which is 3.5. That needs to be a whole number. So therefore, we cannot square root them, which means not factorable. We don't want any decimal numbers in here. Okay, no fractions. Our fourth type of factoring is perfect square trinomials. In these, we need trinomials, so we have three terms. We need to be able to square root the first and last terms. And we also need the middle term. Middle term needs to have the pattern of being, middle term needs to be the middle term needs to be 2 times my result times the other result. So let me kind of show you that. With these, I notice there's 3 terms, and then I'd start square rooting. So I can square root my first one, I get x. I can square root my last term, and I get 4. So this is telling me, okay, it might be a perfect square trinomial. Now I need to check to make sure my results times 2 is the middle term. So in this case, 2 times 4 is 8 times x. So this is the same as this, which means we are good. So this allows me to use the pattern that a squared plus 2ab plus b squared equals a plus b all squared. So I can now write my first thing plus my second result there squared is my factored trinomial. All right, next example. All right, as before, I see there's 3 terms. Now I need to see, can I square root each of them? Well, I've got x squared, which is x. I've got my square root of 9, which is 3. Now I need to do my check. 2 times my first result times my second result, and I get 2 times 3 is 6, getting x. So 6x is not the same as 7x. So this is not a perfect square trinomial. Now this may still be factorable, but we just can't use a technique. So just wait. We'll get to that next technique later to check to see if it's actually factorable. All right, let's try this example. We got 3 terms. Let's see if we can square root it. We can't square root 5x squared, and we can't square root 45. Now, this is not the end. What I would recommend you always do when possible is try and look at the greatest common factor of each term. We could notice with the numbers that all of them are divisible by 5. So they all have a greatest common factor of 5. So what we can do is put this GCF out front like we did before in the type 1, and we get 5 times x squared, 5 times negative 6 gives me 30x, and then we've got 5 times 9 is 45. Okay, so now what we're going to do is kind of ignore this 5 for a little bit and just focus on this part. All right, now let's see if this is a perfect square trinomial. If I look at the x squared, that can be square rooted to be x, and I look at the 9, that can be square rooted to be 3. Let's see if it satisfies our middle condition. 2 times our result times 3. We've got 2 times 3 is 6, so we've got 6x. All right, so we are good. Now we can say 5 times. Instead of doing our first result plus 3 squared, we need to recognize that there is a subtraction here before we had an addition in the middle. So in this case, our pattern is minus 2ab plus b squared. That is going to be a minus b all squared. So we don't do x plus 3. All we do differently is x minus 3. all squared. And then that's just times 5. All right, let's go on to the next one. So can I GCF the 25x squared, the 60x, and the 36? Turns out it's just one, so let's not bother. All right, so let's check to see if this is a perfect square trinomial. We can see that we can square root the 25x squared. We get square root of 25 is 5, square root of x squared is x. And then we can square root our last term. We get 6. And then 2 times our result. We get 5 times 6 is 30 times 2 is 60x. All right, so we are good. That's the same as this. So we can write 5x plus 6 all squared. Done. All right, let's do this messy one. Can I GCF something out here? Turns out you can't, but let's see what we can do. We got a trinomial. Let's see if we can square root all of these. All right, so we got 49x to the power of 4 y squared. So square root of 49 is 7. Square root of x to the power of 4 is x squared. Square root of y squared is y. All right, square root of the last term, we got 81x squared b to the power of 8. So square root of 81 is 9. Square root of x squared is x. Square root of b to the power of 8 is b to the power of 4. So it does work. Let's check our middle term. 2 times our result. All right, so 9 times 7 is 63 times 2 gives me the 126. So we've got the 126 here. So far, so good. We've got x squared times x is x cubed. Then we've got y, and then b to the power of 4. Yeah, that's exactly the same as our middle term. We are good. So we can take, as usual, our first result. And then because it's subtraction in the middle, we write subtraction here. 9x times b to the power of 4, all squared. So even this messy one can be done. All right, here comes our fifth type of factoring. We've got our trinomial of this form x squared plus bx plus c. The key thing to notice here is that we have a 1 in front of the x squared. This is the technique whenever you have this. What you do is you look at what adds up to be the middle term and then multiplies to be my last term. Okay, so you focus on the 8 goes here and the 12 goes here. All right. So you need to choose 2 numbers that satisfy these conditions. To narrow it down for you, if you kind of get stuck, you can find the factors of the last number. So the factors of 12 are, 1 times 12 gives you 12, go up to, keep going up, 2 works, so 2 times 6 gives me 12. Let's go up again, 3 times, 4 gives me 12, and that's it. So one of these 3 possibilities is going to satisfy the condition. It turns out, if you look here, 2 plus 6 gives you the 8. 2 times the 6 gives you the 12. Satisfying both, which allows you to do this. In this case, this type 5 of this type, you can just set up like so. And then what you do is you just grab this, and those just go directly into here. So the 2 goes boom, and the 6 goes directly in there. And you're done. Let's do another one. Okay. So, as usual, as I was saying earlier, always try and GCF before you get started with any of these techniques. So I can see here that the GCF of 3x squared, 9x, and 30 is 3. I can take that out. So what I'm going to do is put that 3 out front. So I end up getting 3 times x squared, 3 times negative 3x, and I get 3 times negative 10. All right, now I'm going to focus on this. What's left over is the one that's of the form x squared plus bx plus c. So I'm going to follow the technique I just used above. So I need to look at what adds up to be my middle term, which is negative 3, and will multiply to be my last term. Okay, if you're having some trouble, think about the factors of your last term. So we're looking at the factors of 10. So we got 1 times 10 works, 2 times 5, and that's it. These can be plus or minus, so you can go 1 minus 10, 10 minus 1, negative 1 minus 10. You can go 2 plus 5, negative 2 plus 5, 2 minus 5, negative 2 minus 5. It turns out that you can go use this guy, and thinking of negative 5 and 2, that gives you negative 3. And then you can go negative 5 times 2, and you get the negative 10. So, as before, we just set it up, and we just put it in directly. So we got the minus 5 goes directly there, and the 2 goes directly there. And we're done. On to our next example. Now this one's a little more challenging. Let me just do something to help us here. Let's focus on writing it like so. You see there's 2 variables here. We're going to do it the exact same way, but just think of the y as like a constant. It's just kind of like a number. So as before, we want to add up to be what's in the middle. In this case, we've got this 7y in the middle, not just a 7. So we got to put 7y right here. And then we need to multiply to be the last thing. Here we just don't have 12, we have 12y squared, so we need to write that in there. So now we need 2 numbers that are going to add up to be 7y and multiply together to be 12y squared. So if you want some help, you can just think about, just ignore the y for a second, just focus on the 12. Find the factors of 12, and those are 1, 12, 2, 6, 3, 4. So you can imagine 3 and 4 are going to be able to be added together to get 7. So you need to be careful though. It's going to be 3y plus 4y to get 7y, not just 3 plus 4. 3 plus 4 does not equal 7y. 3y plus 4y equals 7y. And that turns out to also equal, when you multiply them together, 3 times 4 is 12, y times y is y squared. So you get the second thing as well. So we're good to go. Just as usual, we set up, we have our x and our x. So we've got x plus 3y, x plus 4y. If you expand this out, you'll notice it works. So pretty awesome. All right, another one here. Let's see if this one works. Let's add up to be our middle term, multiply to be our last term. and we got factors of the 8 here. We've got 1, 8, 2 times 4 is 8. That's all we got. Well, you can imagine that maybe negative 2 minus 4 gives us negative 6, but unfortunately negative 2 times negative 4 equals positive 8. So it doesn't work. Will something else work? It turns out you can beat yourself over the head with this and you just will not be able to find two numbers that will satisfy this condition. If that's the case, you say not factorable. All right, finally, we're on to the last type of factoring you typically come across. This one is where our a value that's out front is not equal to 1. So that's where you got 2x squared or a 3x squared or a negative 5x squared. You have to use a slight variation of the last technique I just showed you. All right, so first things first, try to find the greatest common factor in all these three things. We can't actually find anything here, unfortunately. So it means that we're stuck just doing this longest way. In this situation, we need to first go 8, our first thing right here, times our last number. So we've got 8 times 3 gives me 24. So I'll just use it right here. We're going to use that for when we add up. Once again, like before, we're going to equal our middle term of 10. But then we need to multiply, not to be 3 anymore, but this 24. So think about, if you can't think of something that's going to satisfy these two conditions, narrow it down for yourself and think about the factors of 24. We got 124, 2 times 12. We've got 3 times 8. We've got 4 times 6. So choose something that's going to add up to be 10 and multiply to be 24. So none of these work. Nope. Oh, 4 and 6 does. So if I put 4 and 6 here, we satisfy both conditions. All right. So rather than just do this where we went x and just put plus 4 plus 6, we can't do that because look, x times x does not give you 8x squared, and that's what we need. We need to get 8x squared. So it's a little more complicated than this. So what we need to do is rewrite our question, 8x squared. And rather than writing 10x though, we can write 4x plus 6x and then plus the 3. And this works because 4x plus 6x also equals 10x, which is the same thing here. So it is an equivalent statement, but it's strategic. Because we did this pattern and we satisfy it, we can now use our factoring by grouping. So break this down into kind of the two pieces as we did before. And now, if I look at the greatest common factor of 8x squared and 4x, I can pull out a 4x here. 4x times 2x gives me 8x squared. 4x times 1 gives me 4x. And then on to the next piece. The greatest common factor of 6x and 3 is 3. 3 times 2x gives me 6x. 3 times 1 gives me the 3. Notice, as we noticed before when we did factoring by grouping, that we got the same thing in both of these terms. So we've got 2x plus 1 we could bring out front, and then we just write our other terms in brackets like that. So we're done. It was a little lengthy, but this is the best way I've found to handle this type. I would do something like this in the past. I would think, okay, I'd set up like this, and I'd go, okay, how can I get 8? I can do like an 8x and a 1x here. I can do like a 2x and a 4x here, because I know when I FOIL this out, 2x times 4x is going to give me 8x squared. And then I need to try and like guess and check, and it can be kind of challenging to think about what goes here and here, so you'd have to kind of guess and check, kind of expand it out and think about it, do it in your head. And that's what I used to do, but it's not very effective. I find the way I just showed you gets you the answer the fastest. All right, let's do another one here. Can I UCF this? No. Is it a perfect square trinomial? No. So I need to deal with the 6, the first term, the first coefficient there, times, now be careful, this is a negative 12, so I need to multiply by negative 12, and here I get negative 72. All right, so I need to add up to be the middle, so the middle is just 1x, so it's just a 1, and I need to multiply to be the negative 72. All right, think about that. What's gonna get me negative 72? You could trial and error it, but what I do is I look at, okay, I see a 1 here, which kind of means to get 1, I would need to have like 7 minus 6. I would need 8 minus 7. I would need 9 minus 8, or 10 minus 9, or 11 minus 10 to get 1. So that kind of narrows it down when I look at, okay, well, which of these numbers is going to multiply to be negative 72? 8 times 7, no, it doesn't work. 9 times 8. 9 times 8 is negative 72. So it kind of narrows down when you have bigger numbers like this, what to get when you kind of think a little bit logically. So anyways, we can get 9 and minus 8 is going to work. 9 and negative 8. It subtracts, gives me 1, and multiplies and gives me negative 72. So we need to once again just write our question out. So we got our 9x minus 8x minus 12. All right, so we just rewrote the question. Instead of having 1x, we've got 9x minus 8x, which is equivalent. All right, so we want to do this by factoring by grouping. So look at your first two terms. GCF of 6x squared and 9x is 3. I can divide both of those by 3. So I got 3. They each have an x in it. So 3 times 2x gives me 6x squared. 3x times 3 gives me 9x. All right, next one. We look at the GCF of negative 8x and negative 12. So we can do a negative 4 here. Negative 4 times 2x gives me 8x. Negative 4 times 3 gives me negative 12. Oh, nice. Look, it'll always work for you. Same thing in both. And we got 2x plus 3 and 3x minus 4 here. And we're done. All right, final example here. Let's see if this one works out. We can't GCF it, can't do perfect square trinomial, so we're stuck with going 5 times the negative 2 to get negative 10, giving us, adding up to 4, and multiplying to be negative 10. Let's see if this works. And I can't think of anything, so I start thinking, okay, what are the factors of 10? I've got 1, 10, 2, 5. Nope, those are not going to be able to become 4 when I add them, subtract them. Therefore, we can say not factorable. So there you have it. These are the different types of expressions you can come across. If any of these were confusing for you, I'll work on posting some more detailed and rigorous videos that go into these a little more slowly and carefully. Anyways, good luck. Hopefully this helped.